Hello and welcome to my presentation, Inclusive Responses to Diverse Needs, a study exploring technology use in the education of autistic pupils. I'm Verity and I'm a PhD researcher from the School of Education at the University of Southampton. I'm part of ACoRNS, the Autism Community Research Network at Southampton, a cross-disciplinary research practice partnership that aims to improve the lives of autistic children and young people within education through addressing the marginalisation and underrepresentation of their views and experiences. I present this paper with my supervisors, Sarah Parsons from the School of Education and Hanna Kovshoff from the School of Psychology. Today I'm going to be talking to you about research which explored how technology was used within the education of autistic students across 5 schools in the southwest of England. This research was conducted in 2019, way back before the pandemic, and so while I understand some practices may have changed, I feel there is still value in reflecting on the lessons from this work. I'm going to start by explaining a bit about the background, about what autism is and how it fits in with notions of disability and inclusion. Then I explore what research says about technology use in education and the education of autistic children and young people. I will introduce the conceptual framework I adopted and my research questions and describe the methodology for the study. Finally, I describe the results of the thematic analysis and discuss them in relation to the current literature. Within the context of the contemporary educational system, medical definitions such as those contained within the DSM-5 and the ICD-11 are needed to provide criteria upon which autistic people can receive a diagnosis and gain access to additional support. Autism is characterised by both the DSM-5 and the ICD-11 in terms of deficits in social interaction and communication and restrictive and repetitive behaviours. By focusing on the perceived deficits of autistic people, such definitions also miss key differences which are not so directly identified as impairments. For example, autistic people experience differences in sensory perception compared to non-autistic people. Within this medicalised conceptualisation of autism, the difficulties an autistic person faces are seen as being a direct result of their perceived impairments, rather than relating to any contextual factors at the time a difficulty is experienced. However, social developmental accounts of autism emphasise the importance of previous experiences in shaping our behaviour, how we are perceived by others, and how others respond to us, which in turn forms part of our experience which influences our behaviour later on. Outside the medical model of autism, the Neurodiversity Movement defines autism as part of the natural variation of human neurology, rather than as a disorder. This stance also explicitly recognises the role of society in the disabling of autistic individuals. This latter point is of particular importance in relation to my work, as it actively avoids the deficit-focused narrative of personal tragedy which is inherent in medical definitions, and moves responsibility for disabilities away from individuals and towards society, in line with social models of disability and socio-developmental accounts of autism. In the case of autism, disability arises where autistic individuals struggle to meet the expectations imposed on them by the neurotypical society, including in school, where autistic children often require support in recognising and responding to social behaviours, establishing effective communication strategies, transitioning between activities, and coping with sensory stimulation. By recognising the disabling nature of educational environments for autistic students, we understand addressing issues which autistic students encounter in education as issues of inclusion. With this in mind, I adopt the view that inclusive practices practices can occur in a wide range of contexts and types of educational provision, though I understand that a requirement of placement at mainstream provision is the starting point for others' conceptualisations of inclusion. Within this context, I draw upon understandings of inclusive practices which call for environmental change rather than change within a student to ensure access to education. In particular, I find it helpful to reflect upon ACoRNS's 2007 view of inclusion within education as a process which focuses on the identification and removal of barriers to learning, with a view to improving the presence, participation and achievement of all students. International work, such as Freiland et al. And the European Commission's report, has employed quantitative methods and reported increasing use of technology within education, especially in more developed countries. However, these large-scale quantitative studies lack detail to really understand how technology is being used in relation to specific groups such as the autistic community. Much of the research relating specifically to the use of technology for autistic people has focused on the design, development and evaluation of technologies, rather than investigating current practice within education. While some research has focused on the use of technology in the education of autistic children and young people, it has also generally been quantitative. For example, Laurie et al. 2018 report the results of a survey which asked about what technologies were used in the education of autistic students and for what purposes. However, this approach lacks important detail about the context of use. Consequently, I decided to take a qualitative approach which could provide richer detail about not just what is used, but how it is used and in what contexts. In order to examine current practice, I adapt a framework originally used in CSESA Technology Group 2013's report, which was suggested as a way to support decision-making about technology. The framework includes 3 factors that should influence choice of technologies: the educational context, characteristics of the users, and purposes for which the technology will be employed. In its original conceptualisation, overlap between the 3 factors correspond to the ideal selection of technology for a particular context. However, it's not made clear in either case from whose perspective this ideal is seen. Instead, I suggest the overlap between the users, purpose and technology represent the current practice within each context. With this framework in mind, this study has attempted to answer the following research questions, which are shown here linked to the factors they are most closely associated with. They were: how is technology used in the classroom to support the education of autistic children? What technologies do autistic children encounter in their educational settings? For what purposes are technologies used? Under what contexts are students able to interact with these technologies? And what are the commonalities and differences across different age groups and educational settings? In order to answer my research questions, I conducted semi-structured interviews with 10 educational professionals across 5 different schools in the southwest of the UK. Schools were selected on the principle of maximum variation. They cater for a range of children aged from 4 to 18 across a broad range of settings, from local authority funded mainstream schools with autism bases to specialist privately funded provision. The participants themselves were self-selected based on adverts circulated by gatekeepers in each school. They covered a range of roles from learning support assistants and teaching assistants assigned to support individual children to class teachers and school leaders such as assistant and head teachers. Semi-structured interviews were used as they allowed the flexibility to clarify and expand upon points raised by the participants, which is necessary for the negotiation of meaning between the interviewer and the interviewee. I followed a similar interview schedule for all interviews to ensure reliability of each interview. I also stuck to a consistent procedure for each interview, including the process of transcription, coding and analysis. Ethical approval was sought from the university, and each participant gave written informed consent to take part in the study before the interviews commenced. All interviews were recorded and transcribed before I conducted the thematic analysis. Analysis began with open inductive coding. Following this, I reviewed the open codes and aggregated them. This new coding schema was then applied to the whole dataset, and some of the initial codes were grouped into initial themes. At this point, I reviewed my original research questions and adopted a slightly more deductive approach. New codes were added, in particular relating to the types and purposes of technologies, and these were applied to the dataset. Finally, I reviewed and reorganised my themes to account for the new codes. Themes are grouped here according to the 4 essential parts of the conceptual framework: technologies, purposes, user characteristics, and context. I start by examining what technologies participants reported. Despite the differences across the settings with respect to the age and needs of the children and young people they educate, some technologies were described consistently. 4 technologies were reported consistently across all schools: interactive whiteboards, laptops and desktop computers, touchscreen tablets, and the internet, especially access to YouTube. Interactive whiteboards were described in all contexts, which echoes their uptake across schools generally. They were described as being used consistently for delivering lesson content. For example, participant 3 said, "I always do my input on an interactive whiteboard, usually using a PowerPoint or Smart publication." In contrast, the uses of the other technologies were less uniform, reflecting their multifunctional nature and the way they could address the differing requirements of each setting. Additionally, some schools reported using mobile phones, cameras, games consoles, headphones, sensory rooms, robots, and other electronic toys. Regarding the purposes of technology, I found there were 4 main ones: managing behaviour, research, supporting pedagogy, and promoting inclusion. In the case of managing behaviour, participants reported using technology to carefully regulate sensory stimulation. For example, participants reported using unusual sounds and pictures to engage students in content delivery, but they also noted that overuse could lead to disengagement. They also described how some students used particular technologies to regulate their moods, such as one student who used the computer at the beginning of the day to de-stress from the long taxi journey to school. Access to technology was also noted as being a strong motivator for many students, and so several participants described using technologies as rewards to incentivise good behaviour. Research was also an important use for technology. Participants reported that both staff and students used technologies to find and share information in lessons across a wide range of subjects. With respect to promoting inclusion, participants described using technologies to remove barriers to a range of activities including communication, reading and writing. iPads were used as communication devices in one school for several students, and the practice of providing students with laptops instead of relying on pencil and paper when writing was described in several schools. Additionally, one school reported using reading pens to remove the need for teaching assistants to sit with students when reading, and also allowed students to access more advanced material for students who struggled with word recognition but not comprehension of text. These different barriers in different schools might reflect the diversity of students across participating schools. Technology was also reported as being used to support pedagogy more specifically. Interactive whiteboards were noted as being used to increase activity in the classroom, as students were invited to come and contribute at the board. But this was not used consistently, with many reporting that this form of interaction was rare. Several schools subscribed to programmes to support learning of particular academic skills such as literacy and numeracy, and accessed them regularly. Technology was also used to capture and share students' work. Cameras were used to photograph activities and progress, and digital exercises such as writing on laptops could be shared on the whiteboards. Participants described how sharing work in this way could promote self-esteem and pride in students' work. In some cases, academic uses of technology was even noted as being extended to leisure times, where students would choose to come back and engage with activities from the lesson during times which were less structured. There were two sub-themes relating to the context of technology use, which was discussed by participants from every school. These themes are agency and barriers to technology use. Agency here relates to the extent to which students are able to make decisions about the way they interact with technology. In all schools, technology use was described as being highly restricted, with few opportunities for open choices or unstructured interaction with technology. Even when more free time was given, such as during soft starts, adults monitored closely for the appropriateness of interaction. This relates to the quote given on the slide, which was said by one of the teachers who allows more free time with technology through soft starts. As long as they're doing things that are within reason, they're allowed to do what they want. As this quote demonstrates, notions of appropriateness seem largely determined by adults. Overall, older children appear to be slightly less restricted in their access to technology, but their interactions are still closely supervised. This restriction is first and foremost justified by the duty of care which each school has for its pupils, and ensuring pupils meet the educational objectives and goals set for them. However, some restriction is related to different barriers. Cost of equipment is one, which, as you can see from the quote, can have considerable impact on the way students are allowed to interact with technology. This also feeds into the age and lack of functionality of equipment, which restricts some technology use. Participants described being unable to install new programs on older devices, which was restrictive. Many participants complained about devices which could no longer support new software due to their age, and this was a limiting factor in what teachers were able to offer for their students in class. Other barriers mentioned related to the attitudes and knowledge of staff and the pupils themselves, with several participants describing pupils simply refusing to use particular technologies with little explanation as to why. Moving on to factors relating to the user's characteristics and how they influence current practice, I found two main themes: how characteristics typically associated with autism affect interactions with technology, and how preparation for operating in a neurotypical adult world shapes interactions. On the one hand, I found that the diversity of the students, even within a single classroom, meant that personalisation of technology was often very successful. One participant described that they had personalised a communication app to include people, places and objects that were particularly relevant to the child using the app, and continued to explain how the child had also gone on to personalise the app further herself. She noted that both the child's expressive and receptive language had improved noticeably in the time since she was first given access to the app. Several participants also described how technology allowed them to tailor their lessons to the intense interests of the children in their classrooms. They noted how this could be really helpful in getting students to engage in subjects they might otherwise not be motivated to work on. However, this always needed to be carefully balanced, as including intense interests could push students away from the focus of the lesson. For example, one participant said, "The special interest helps to push them into the lesson and get the most from the lesson, but maybe they then start to look at their special interest a bit too much. They're back on a Pokemon site when they should be looking at geography." Similarly, some participants described how some students could become very fixated on technology. One teacher described how she had needed to remove all access to iPads, apart from one session on a Friday, because she had felt her class were becoming too obsessed about them. And another told me about her attempts to widen their students' interests outside of technology during free time. On the other hand, participants described how current technology use was also intended to prepare students for adult life and the demands which would be placed on students by a predominantly neurotypical society. Participants described how working in groups was a skill that many students would need for adulthood. They described using technologies to encourage group work through the use of specific games and limiting the number of devices available to students. Waiting and turn-taking were the main skills which participants felt inhibited group work, though the picture regarding these skills was not entirely simple. Participants described how their students found the waiting associated with turn-taking difficult, meaning that activities which involved everyone waiting for long periods were generally avoided. Examples of this include student interaction with smartboards, which participants limited as it often meant the class would have to wait while each student had their turn. However, some also described how their class were good at waiting in certain contexts for activities where it was expected. Finally, participants described the importance of developing technology skills, such as digital communication skills, as these were considered to be essential for adulthood. Examples of this included learning how to make phone calls and negotiate internet-based messaging. Several participants described how students needed to learn the implications of these technology-based communications, saying they had experienced issues between students where they had not realised the consequences of insulting messages sent online. Many of the findings I have reported here coincide with the results of quantitative investigations into the use of technology within educational settings. For example, the frequent use of interactive whiteboards coincides with work by Lewin Samek and Stedman, 2008, and the large-scale reviews of technology use mentioned earlier. However, there is a stark contrast in the way in which participants report using technology within the classroom and the focus of much of the autism and technology literature. Specifically, the literature largely focuses on the design, development and evaluation of autism-specific technologies. However, I found little evidence to suggest that such technologies are used within educational settings, or that these technologies are commonplace, at least within the schools included in the sample. What's more, the use of technologies stretched beyond the broadly therapeutic focus of the autism and technology literature. Though technologies were reported as being employed to overcome specific struggles and challenges facing autistic students, the focus in these cases seemed to be on changing the environment to enable students to access learning, rather than changing the students themselves or their behaviour. In this way, I see technology use within educational practice as being much more inclusive than the literature would suggest. With technology focusing on the environment rather than the child, and being centred around ideas of removing barriers to learning and promoting participation and achievement for students. In this way, more technology reported here might be considered instances of inclusive technologies, or technologies being used to increase inclusivity within education than might be expected given the focus of the literature. With respect to potential limitations of the study, attempts to maintain a consistent interview schedule were not wholly successful, as I changed from trying to ask detailed questions while participants described a day to allowing them to describe the day fully before going into detail about each technology. Perhaps a more experienced interviewer might have seen that this would be better in advance. However, as reports were similar from participants within the same school across the different interview structures, I do not think this change in structure affected the interviews too greatly. Furthermore, though the semi-structured interviews yielded rich qualitative data, this data only reflects the perspectives of teachers and not the students. Given the findings I discussed, it would be prudent to investigate their perspective about whether technology is furthering their own experiences of inclusion in the classroom. Finally, as this data was collected before the pandemic, it is likely that the technologies and practices used within the education of autistic children has developed considerably within the last 18 months. As we have all experienced, the pandemic has forced us to embrace virtual conferences and teaching to a much greater extent, but this was than would have been described within the study. Future work might also investigate further how the pandemic has affected these practices and the attitudes of both autistic students and staff towards the use of technology with education. In summary then, during this talk I have presented the findings from 10 semi-structured interviews from a diverse range of schools catering for autistic students across the southwest of the UK. Some of these practices coincided with findings from other large-scale research in the same area, such as the use of interactive whiteboards for delivering class content. However, I've expanded on these findings by providing more detail and context for them. Within the data, I developed 4 themes which encapsulated the practices described by participants. What technologies, purposes of technology, technology in the school context, and autistic students as technology users. Together, these themes suggest a much more inclusive approach to technology within the education of autistic students than would be suggested by the literature, which is often deficit-focused and concentrates on the use of technology as a therapeutic tool. Instead, within this talk, I have positioned technology as a tool which facilitates inclusive education, which educational practitioners employ to change the educational environment and reduce barriers to learning for autistic students.